So yesterday we are talking about the row based and the column based. So here is an example where we can elaborate much more detailed. Okay, for example, okay, so how to take the row based and the column based. So why the SAP HANA made it as a column based as it's a mandatory for any setup of tables. Okay, so yesterday I went into the technical point of view where we can set the row based and the column based. Yesterday, if you see that I have given an example as a BSEC table, and there we have seen that okay, there are three storage types. There one is the row based, second one is going to be called as a column based, and the third one we call it as undefined. I'll tell you what is the undefined also. Now in this example, if you see here, I just take an example. So here there is something called as a okay. So here there is something we can also explain based on the technical, the logically how it is going to be working when it comes to the column base to the row base to the column base. So, but let me take as an easy example, and then I'll explain you the concept of how the system is going to compress the columns. Okay, how the compression is going to be done at the column based, and how the compression is going to be made at each and every column wise also. Okay, so take an example here. Now, in this example, we can see here there are three. Okay, there are three rows. Okay, there are three columns are there. One is going to be called as the country, person, and the quantity. Okay, so I take the same example here. Okay, so I'll take the same example. Okay, not more than that. Okay, so it will be easy for us to understand. Okay, now here I'll take the country. So the country where exactly the person is going to be resided. So I'll take the person and the quantity also. And the quantity. Okay. Now, so this is one of the database table. You just treat it as one of the database table in our SAP. Okay, so I'll take about the France. So country is going to be the France. And here also we have, okay, it's two different column wise. Okay, we have France over here. And we have the UK and Germany. So one more column, okay, one more row has to be inserted. Okay, UK, and this will be your Germany. So why I'm putting the diagram, I can directly explain over here by saying about this, okay, the slide, but it will not be so, okay, so effective in listen, okay, in making you to understand. So that is the reason I'm putting the diagram. Don't take it another way. Okay, so please, okay. So it is a Germany. Very good. Okay, so here we have got the countries. We have got the countries in a database table. Take any table. Okay, it's not a compulsory that I'm taking the BKPF or BSEC or any table. Take any table here. Okay, so the person who is supplying the quantity of the material here, I'm going to be taking some person who is going to be, the name is going to be called as a Ned, and here I'm going to be calling it as a Tony. Okay, here I'm going to be calling it as again Ned. He's supplying the same material. Okay, he's supplying the material. Ned is supplying the material in both the countries. If you see here, Ned is supplying the material in France and is supplying the material in UK also. Okay, so here I'm going to be taking, okay, so some other name. Okay, ANIT. Okay, so here quantity 10. 12, and here I'm taking the quantity as a 8 and 4. Now, yes, this is what exactly. Now I want the data. I want the data now. So I'm just sending a query to my SAP for, okay, I'm sending a query to my SAP. What is the query? The query here is, okay, Ned, okay, who is the person? Okay, I cannot tell who is the person. I want the data of the Ned who is supplying. Okay, so Ned is our person who is supplying the material and the quantity in which countries. Okay, so I want the data like this. Ned with based on the country and what is the quantity of the material he is going to be supplying for me. Okay, what is the total quantity he is supplying? The total quantity I want. Okay, net total quantity. Total quantity. I want the total quantity. Okay, this is my query. Now, if you see here, when I'm saving the data, here, so the first row, whatever be the first row you have inserted earlier, very, very important. The first row in the back end, it will go and it will store in a file. Okay, first one. And when I have entered the second column, when I have entered the second row, again, the same second row will go and enter the parallel to the same row here. See, very, very important here. Okay, now just there is no space, so I just include this here, please don't. Okay, so third one, again it is coming in the same file. Okay, so in the same file it will go and it will store here. So actually there is no space, so I'm putting here, please. Okay, so there is no space, I'm putting over here. Okay, and the third one, so it will be, so in the same table, in the back end we can see some files are going to be created. So here the data is going to be stored like this. Now when I'm sending a query, to my SAP, the total quantity of the material, total quantity of the material the person net has supplied. So what is happening? The SAP, what it will do, the query, whatever the query you have sent to the SAP, it will go and scan the entire row. First, it will scan the row number 1, very, very important. And from here, it will pick up the name and it will put out here in a separate. Okay, so pick up the name and total quantity is going to be the 10. Okay, next, again it will go and it will scan the second row, and here it will not find any name by the Tony. Okay, here it will not find any name by the name of Ned. Okay, so this particular row in the file is going to be eliminated, and parallelly it will go to the third row. Okay, it will go to the third row, and here again the same person net has supplied the material. The same person net has supplied the material of total quantity of H. Okay, now I know by seeing the diagram I can know that now there is no net. So but still the SAP, what it will do, it will go and scan all the rows, and it will finally, what is happening, it has got the data now. It has got the data. Okay, now this data has got it from 2 tables. Okay, example. Okay, from the 2 tables, one is example here, one is called as, okay, BKP, one I'm going to be called as MKPF table, and another one is BBAK table. Okay, and this example. Now from these 2 tables, okay, this SAP, the query has worked and it has got the data. Now the database, what it has to do, yes, it has by the processing, by the core processing, by the disk processing, it has got the data from these 2 tables. But now what is the problem? The database has to compile the data. Now the database, it has to compile the data, and it has to compile the data in a form of a report, and the report has to come to your GUI, graphical user interface, where the user is able to see the total quantity the net has been supplied. But what is happening here? The database, whatever the database existing, my traditional database, as it is the Oracle or MSQL or any database you can take except HANA. I'm not talking about the HANA database. Now what it is doing here, actually it is not able to compile the data. It is only serving you as a database only. It will only give the data what you have requested. But I am not able to compile, but I don't do any compiling of the data. Very, very important here. So who has to do this compiling? The compiling has to be done by your application. Very, very important. Now, what this query will do here, this query will push these database tables to your application. And what this application is going to do, this application is going to compile the data now. This application will do what it will do, compile. It will do the compiling of the data. Compiling means what it is doing, these 2 database tables will be developed as a report, and that report will be given back to your presentation. Either it can be anything over there. So what is happening here? The database tables are going to be scanned in each and every row, to pick up two important information. One is going to be the person, it will be picking from the MPPF table, and another table which is going to be picking the total quantity of the material he has been supplied to my company. So only these two data, only these two information which is required. But that what the system is going to do, the system is scanning all the rows in the table, and finally I'm going to get only two informations in my database table, and after compiling I can see the reports. This is what exactly what we are going to be expected? No, this is not exactly what I'm going to be expected from the database. But there is no other way, because till 2010, before the HANA database has been introduced for ourselves, there is no other way. We have to be as a tenant of other database systems like Oracle, DBMS, RDBMS, MSQL, nothing but. That is the reason we call them as a secondary access device. All the databases, we call them as a secondary access device, because we don't have our own data. We don't have our own database system till 2011. Now, when I have made, yes, once my database of HANA has been introduced. So what I had done, I removed this logic. I completely removed this logic. Yes, no, I don't want this logic should be executed, because I have the parallelization and the partitioning mechanism is there in my SAP HANA database. Very, very important, my dear friends. Very, very important. In my SAP database, I have the advantage of parallelization and partitioning. I have the parallelization and the partitioning mechanism in there. So using this parallelization and the partitioning, what I have done, I had changed all the database tables, mean to say that now the storage type has been changed from the row based to the column based. So how many? Okay, now here I'm going to be taking here. Now, first one, this is the first. This I call it as a country. See here, very, very important. Country. Second, this I call it as a person. Third one, this I call it as a quantity. Very, very important. Now, if I see in my first column, so how many countries are there? Okay, country, France, only France. I'm not going to take the second column. I'm not going to take the second row here, only because both the rows are having the same country. The second country is going to be the UK, so it will be stored in one, and the third country is going to be the Germany. Very good. Okay, now, so here's something. Okay, so if this is the person and this is okay, something. So what I'll do, I'll just share this. Okay, now, so I'm just taking as a German, and here the person is going to be okay, Ned, and here I'm going to be taking the Tony, and here I'll be taking as a third one, which we are going to be calling it as Anita. Okay, now when I come to the quantity, 10, 12, 8, and I'll be taking as a 4. Okay, now see here. Now I have only 3 columns right now. So here, if you see here, I compressed one row into one column. Here you can see here, I have, if you come to the country, there are 2 rows are there. France is going to be the same country, but it has been occupied with the 2 rows. But here I've been compressed with 1 row only. Okay, with 1 column here, you can see here, very, very important here. So that there is a compression. I can see the data compression over here. Now the same data, when I take in my Oracle database or any other database, I can see this is totally comprising about, okay, 10 MB of the data. Example, 10 MB of the data total. Now, when I brought the same data, when I have migrated the data from your Oracle database to SAP HANA database, the same data I have been compressed up to, okay, 5 MB. Means half a data has been compressed over here by removing the duplications, by removing the redundant data. We can call it as a redundant data. All the redundant data has been completely removed over here. So in this example, I have removed the redundancy of the France and I made it as a one country over here. So I can minimize the database compression from the 10 MB to 5 MB over here. Example, okay? Now the same logic. Now you come to the same logic. Now I'll come to the same logic of same query which has to be executed from my Oracle, from my SAP HANA database. Net total quantity of the report. Net is a person, total quantity of the report. When I send this query, when I have sent this query, what is exactly the logic here? One, the logic is going to be based on the person, and based on the quantity only. Based on the person and the quantity. Nothing more than that. Nothing more than that. Okay. Now, what it will do, so it will not go into the country. The query will not go and it will not scan the column of the country because the query is totally depends upon the person and the quantity only. So here, from here, it will go and scan the person and it will go and scan the quantity, not the country over here, because my query is very strictly telling to be scanned only based on the person and the quantity only. Now, from here, I got the data and I'm displaying the data over here. The total quantity of the net is equal to 18. Now is equal to, this is what exactly I call it as an algorithm. This is called exactly, I call it as an algorithm where I'm going to be putting in the row base to the column base. Now you can see here, it is not going to scan the country, it is scanning only the quantity and the person. Why? Because the query has been designed in a such a way that it has to not to go to the country field, it has to go to the person, and the total quantity of the net he has supplied to me is going to be the 18 over here. Now you can see the throughput. The first one, I see the compression of the data, and the second point, I can see the throughput. The throughput between the row based and the column based. The throughput between the row based and the column based. 10 MB of the data here, first one, 10 MB of the data which has taken for me to get the report is approximately about the 15 seconds. 15 seconds. Very, very important. Now, 5 MB of the data, 5 MB of the data, which has taken me only not more than 5 seconds. You can see the data. Now, tell me now how the high throughput is going to be designed for your HANA database, where the low throughput has been designed for your traditional database system. So this logic, how it is going to be working in the backend, the logic which is going to be working in the backend is going to look like this. This is the complete footprint of your reducing database footprint of the logic you can see here. Now, the same example, it has been explained in another way. This is the standard SAP example. Actually, this is not designed by me or anybody. This is the standard example released by the SAP. 1 second, sir. Can you please hold on the line? Somebody, please. 1 second, sir. I'm getting a call. 1 second, please. Don't mind. Now, when you come over here, now we have totally order, country, product, and the sales. There are 4 rows are there. Now, when I compress the data of the country level, because I want to compress the data, I cannot compress the data based on the order number because the order numbers are going to be the different over here. Now you can see here, the sales order numbers are going to be the different. If we have the same sales order number, I can compress based on the sales order number, but there is no choice of but there is no choice of compressing the data at the order level. When I come to the product, there is one option is there where I can compress the data based on the product and based on the country. But here also I cannot compress the based on the sales also. So there are two options are there where SAP can do the compression of the data. My HANA database can do the compression of the data. One is at the country level, another one is at the product level. Now, when you see here, when the compression is going to be done when the France level, there is no other column which is consists of the France, no, nothing to do with it. Now, when I take the Italy, one in the row number two, in the row number in the column number two, in the column number four, in the column number, okay, 8. Now here you can see here I'm compressing the 2, 4, 8. See here 2, 4, yeah, the indexes are going to be columns compressing the data. Which orders has to be compressed based on which orders are going to be in the Italy. So I'm compressing the data. Second one, I'm going to be compressing the data. Now the second one, Denmark is also there. Okay, so Denmark is in which, okay, in which column? 1, 2, 3, 4, fifth column. So you can see the fifth. So Denmark is going to be repeated 2 times. So I'm compressing the data for the 2 times. So what is happening here? So I'm compressing. See, the logic is going to be working in the columnar beta database where I can compress the data and I can have the query do the analysis. Means the query has to do the scanning based on the column base, not on the row base. So based on the situation, so my dictionary has been developed. Internal dictionary has been developed based on only the 5 countries. Even though if we have the same country is going to be repeated, as I told you the example here, even though if I have the country as a France, both appearing as a 2 times, but I have made it as a France as a 1 dictionary in my database tables. So what is happening? I have the space, I have the lot of space where I can also store some more data into the database with the other countries not replicated with the same country of the France. This logic is called as columnar with the row base. So when I go into the SAP, so now I go into the SAP, 1909. So what will be the prime or foreign key to pull the data from the reporting in the column base? Actually, so the prime key is going to be based on the query which has been designed. So now we don't have the indexes tables over here. Now we don't have the secondary index table. So there is, after this there is a one more. I'm going to be explaining the logic of redirecting and reading the data from the database table. So I'll explain there over the column. Okay. So what does it store the relationship between the quantity of, just now I told the relationship is going to be based on the country or whatever may be. So what logic you are going to be taking, that is going to be the relationship, because I don't know what is the total quantity. I don't know what is who is going to be supplying the material. So the logic which I have designed is based on the quantity and the person here. Now, if I go to SE11 transaction code, I'll show one example. Okay, I'll show one example. So we have the BSEC table. We have the BSEC table. Now, the BSEC table in SAP, we call it as an accounting document segment. Very, very important now. Okay, now when I go to the technical settings of the same table, now here, when I click on the database specific properties, here you can see the database table storage type has been maintained as a columnar storage type. Now I'll go and log into the SAP ECC. Okay, so here if we see the table structure may not exactly that only the HANA database has to be get into the columnar storage and the row based storage, so no other databases can have this storage type. You can also have the storage type depends upon the row based and the column based in other database also. We are not telling that other databases cannot have the row based and the column based, only the row based can work, no column based can be worked. Others also can work, but the logically speaking over there, the column base cannot be so supported in other database because they don't have this parallelization and the partitioning mechanism. So there, a lot of the people are asking the same question in my SAP TechEd. When I've been there in the SAP TechEd also, most of the people have asked the same question to me. Okay, so what is the question here is, when I've been there in the SAP TechEd, okay, in the Sapphire also, SAP Sapphire also, most of the consultants from various countries, they asked me one question, Rahul. Okay, now when you take one database which is going to be calling it as the Oracle. Okay, Oracle is a database. Now you're talking about the HANA database. Now you're talking about the HANA database. Now in Oracle also we have two different storage types. One is going to be the row based, and another one is going to be the column based. Okay, but now you're talking about the HANA also. In HANA also, okay, very good. Okay, so that in HANA also you have the two row based and the column based. Now, why you always tell that? Why you always tell that now the HANA is going to be having the column based, where the Oracle is going to be having the row based? Why you are insisting a lot on that? Even though if you go back to the Oracle, Oracle also can have the column based. I can shift from the row based to the column based. Now, whatever the things you are explaining here, in the pattern of your HANA database, to show the importance of the HANA database, you are making this making lecture to us so that we can understand. But when you go to the Oracle also, I can give the same lecture. Even the Oracle database is also having the same features what you're talking about the HANA, but you're missing one logic. But in the Oracle database or any other database, my dear friends, we don't have this parallelization and the partitioning mechanism. No, nothing like that. We don't have this parallelization and the partitioning mechanism, even though if your Oracle database storage type is on the columnar storage, how we have done for HANA, even though you are shifting from the row based to the column based. Even though, see here, this is my SAP ECC. This is my SAP ECC, not SAP S4 HANA. EPX system, SAP ECC, the database, yesterday I showed you, the database is not a HANA database. It is an MS SQL database. If you see here, this is not a HANA database. It's a different database, but in this database also, I have the columnar storage. In this database also, I'm showing the storage type as the columnar. In your HANA database also, this is the HANA. Now, when I come to the system and go to the status in your HDB also, this is the HANA database. In the HDB also, in your HANA database also, you're showing the same columnar storage. Both are going to be the same. What is the difference over here? The difference is coming not from here. The difference is coming from the parallelization and the partitioning. Very, very important here. I have the parallelization. Now there is no locking mechanism between the one processor to another processor in my SAP HANA database. There is no locking mechanism. Every processor is divided with one partition over here. So I can have the fast retrieving of the data where the throughput is going to be very, very high. But when you go to your MS SQL database or your Oracle database or any other database, even though if your storage type is shifting from the row base to the column base, but you are missing the logic of parallelization and the partitioning, where there is a locking mechanism is there between the partition to partition between one processor to another processor. Even though you are making the row base to the column base, the logic of high throughput cannot work in your Oracle. How I'm going to be executed in my HANA database. So that is the reason I'm making my HANA database as a global approval database for all the database activities. So this is exactly the answer. This is exactly the answer why we had to go with a columnar with SAP HANA database system, which is called as a storage type. I just explained that theoretically. Okay, so logically in the back end, because we are not so efficient about knowing about the databases, because we are not talking about how the database is going to be working as a logical, because we are not a technically strong in the databases. But as a functional, it is very, very important for all the consultants to know how the functionality is going to be working. Don't go into the deeper level and don't go and understand yourself about what is the technical but what is the technical experience which are working in the back end of the program. Don't go into the behind. Otherwise, you will forget all the SAP S/4HANA also. Is it clear to all of you now, friends?
Yeah.
Problem.
Okay. Now, there is one more important thing. As I told you yesterday also, so one of our friend is asking about the same question. Yesterday also, one of our friends are asking the same question over here. Now, when I'm bringing the data, two things are there. Okay, I just put out here. Okay. Sir, if anybody has any doubts, okay, you can put me the compressed column and the inverted index where it is stored. It is going to be stored in the database only, sir. No other way. Okay, it is going to be stored in the database only. Okay. Now, three things we need to understand. One, very, very important, traditional database. Traditional DB, very, very important. See the so I'm putting on the traditional DB. Business suite on HANA. And here I'm going to be bringing SAP S/4HANA. Three things, very, very important, my dear friend. Three things I'm going to be putting. First, I'll show
Mahesh, can you just run a BSEG report on S/4HANA and show us a table how it looks like, please? Just like 1-2 entries. We don't need the whole list of entries, please.
In SAP S/4HANA, sir?
Yes, sir, please.
So can I go to the SE16 level?
Yes, I just want to see how the table report is shown in BSEG.
Okay, correct. I'll go to the SE16 and I'll give the BSEG table. Now I'll give all the data. See, I'll give the company code. See, I'll give all the company codes. Okay, not restricted with one company code. Okay, I'm giving all the company codes. Now for the year of 2019. Now I'll remove all the 500 ins also. Let me bring all the. Okay, let me bring all the table. Okay, now I'm clicking on execution. So this is the table, sir. Now, when I go and select one of them, now you can store here. Now you can see here. Clear, sir?
It still looks like a row storage, right? It does not look like a column storage. So
no, no, you're not getting my point over here. So the logically, it is not exactly you can see in the row storage or column storage over here, sir. The backend it is going to be done, but the report execution.
Okay. It's in the DB. It's in the column level.
This is the output we are going to be getting as a ALV.
Got it.
Yeah.
Thank you.
Okay. So you You're talking. You want logic behind the. I understand.
I got confused. I thought that now the table views will be a column level. So
I'll also take you to that table also. Don't worry, sir. Just give me 1 day. Okay. We are in the continuation of the classes. I'll clarify your.
Thank you.
Okay. Now.
Thank you.
Let me take out something. Okay, there is a one PPT, there is a one slide with me which will explain me more into that, because all this PPT I'll give it to you, don't worry, because whatever the PPTs which I'm showing on my desktop doesn't mean that it is only for my point of view. So no, not like that. You are going to get all these PPTs also afterwards here. And this PPT I just want to explain you all of you. So yesterday we are discussing about the hot data and the cold data, sir. Everybody you can say we are discussing about something called as the hot data and the cold data. Now the actuals and the historicals means, what do you mean by actuals over here? When I see the database, my database has been designed in such a way that, okay, so it is a multi-tenant database. I can call it as a multi-tenant database. One database, we have multiple databases are there. So something like I can say there is a disk processing is there. There is a in-memory data, DB1, DB2, DB3 databases will be there. And apart from that, my CPU is there. So there are multi-tenant databases are there. So this is what exactly I call it as the DRAM. Yesterday we discussed that, in-memory. And this is my core processing. That is nothing but disk process. Okay, this is called my disk processing. So as I told you that now all the actuals will be stored in the DRAM. DRAM actuals are nothing but, so I want my database RAM is going to be up to 1 TB. So my database RAM is going to be up to 1 TB, and my disk process RAM is going to be up to 2 TB. 2 TB. I can take like that also. So proportionate or undefined proportionate I can take here. Now, when I take in the DRAM as a 1 TB of the DRAM, so how much data I can reside it based on the number of transactions depends upon the company to company also. But example I'm giving. So approximately I can store up to 2 years of data here in this example I'm telling. Okay, don't take into consideration. Example. Approximately 2 to 3 years of the data I can have this database capacity. 2 years or 3 years maximum. Now, this current 2 years of the data, when I call it as a 2019 and 2018, 2019 and 2018 data is resided in my DRAM, and all the historical data I just maintained in the disk processing because I don't require those data as of now, so let it be in the disk process. Now the actuals of the current year and the previous are going to be stored here, so I call it as the hot data. So this DRAM, whenever I am executing any Fiori reports, F-I-O-R-I, Fiori is nothing but my front end from today onwards. Fiori is the front end from today onwards, my dear friend, very, very important here. Now, it is working completely on the UI5 application. There is a new application has called as the UI5 application. So you can have the reports on 2 levels. One is at the Fiori level, and also you can have the reports at the presentation level, which you call as the GUI. This is called as a GUI. This is called as a GUI. Now this is completely, we can call it as a GUI front end. This is called as a GUI. Where is the Fiori? Fiori is here. This is the Fiori. I'm logging to the Fiori now. One second, here the data is not set up. Okay, 1 second, sir. 1 second, please hold on. Here, let me what happened?
I think you got the word trainer wrong there, Mahesh.
Yeah, trainer is wrongly spelled.
Oh, sorry. I'm extremely sorry for that. Now it's correct now? Okay, now it's still it is. Yeah, thank you. Thank you very much. Yeah. We can get the Fiori on 1909 also. So I'll request my support team to get the Fiori on 1909 for your practice. Okay, so don't worry. So just I'm explaining, showing all the things in the 1809 now. This is my Fiori. Fiori is nothing but a flower. Fiori is nothing but a flower actually. Please remember that Fiori is nothing but a flower. Now, if you see here, okay, so what I will do here, okay, so I'll execute one Fiori app, okay, which is related to display manage, okay. So I'll go into the SAP. This is my GUI. This is my GUI, graphical user interface, accounting, financial accounting. I want to get a one report or something like account. I'll go to something called as a display balances. Here we have the display balances. This is my display balances screen. Now the same thing, I'll go to my SAP Fiori. Okay, so Fiori, this is my Fiori. I'll get all the apps over here. So it's completely based on the row based. It is completely based on the role based, ROLE, role based. Okay, so let it come. I'll explain you. Okay, now if the same report, now when I'm executing the report from the GUI as a front end, if the same report, if I'm executing from the Fiori, now what is happening? Now the Fiori will have the logic of what data, and it will consume the directly data. The Fiori is consuming the data directly from your DRAM from here. Directly it will consume the data from the DRAM. Now what is happening? So I'm making the speed. Okay, so the means is to say that, okay, so the acceleration is very, very good when I compare the report from the GUI with the help of Fiori. I'll tell you, I'll take you to the more detailed way. Okay, so not the right time for us to go into the detail. Okay, so now because we are in the explanation about this in memory, columnar, parallelization, partitioning, and everything. So redirecting and directing. So let me put on hold about all these kind of Fiori complications. Okay, in the next coming classes. Now, this Fiori will consume the data. So whenever I'm executing any report from the Fiori, so it will directly go and it will intake the data from the DRAM. Now, when I go and see the slide here, all the actuals means the current year and the previous year of the data is going to be stored in the DRAM, and all the historical data you can see it is going to be stored in your disk process within the same database. It is called as a disk processing. Now, traditional DB, when I take a traditional DB, either it is MS SQL or Oracle or NetDB, the same 593 GB of the data is there in the database system. Now, when I bring the same data onto my HANA database, when I'm migrating the database from your traditional database to SAP HANA database, it's not application, it is a database. Now I can see 593 GB of the data has been compressed up to 118.6 GB. Where is 593? Where is 118.6 GB? Just now I explained to the logic, my dear friends. I completely removed all the redundancy of the duplication, because I removed all the duplications from my database system. Now you can see the compression of the data. Where is now here I shown about 10 MB of the data is there in the Oracle database. Now when I bring the same database with the columnar storage, I'm compressing up to 5 MB of the data. Same thing here. If you see the logic, also the same thing. The SAP. This is the SAP diagram, not by my own SAP diagram only. I can see the compressing of the data has been happened up to 118.6 GB. 200%, more than 200%, I can see the compression of the data. Now you can have more data can be stored in your database. Next one. When I see the database, now what is this? This is called as Suite on HANA. Okay, see here. This is called as Suite on HANA. This is my SAP Business Suite. This is my SAP Business Suite on HANA. There is a difference is there here, okay? SAP. So I'll write S. Okay, Suite on HANA. And this final diagram which I'm going to be putting, this is my SAP HANA. SAP S4 HANA. There is one more is also there. Let me don't take it to the same. Okay, actuals I'm going to be explaining over here now. Okay. Now, what is SAP Business Suite? Means your underlying application is on MS SQL database or your Oracle database. Anything you can take. Okay, so your database is on MS SQL database. This is called as my SAP Business Suite. Your SAP application has been resided on the secondary access device. This is your ECC application. This is your ECC application. SAP ECC application. Where is your SAP ECC application? Your SAP ECC application has been resided on the secondary access device. We can call it as the MS SQL or Oracle or any other databases. Now we call the system as the SAP Business Suite. Now, when I brought the system, when you are having the same application with SAP HANA as a database, when you have the same application, I'm not going to change your application. Your application is on the same, that is SAP ECC only. But when I come to the underlying database has been migrated. See the word I'm using, migrated, not the conversion. Don't use the word called as a conversion. Many people will use the called as a conversion. No, it is called as a migration. your database has been migrated, but I have not touched your application. Your application will remain as it is. Means I have not done any kind of simplifications here. Just I migrated your data from the MS SQL to SAP HANA database. SAP HANA database. Here, the complete data is going to be 593 GB. And here, when I migrated your data from your MS SQL to SAP HANA database, it is 1118.9 GB. See the difference here. How? Point number one. How? Point number one. One is very, very important. One is in-memory concept. Second one, parallelization and partitioning. Third one, advanced compression. Advanced compression, very, very important. This is what exactly I had to use here. I can do the compression of the data. And fourth one, instant insight. I'll tell you what is the instant insight. Because of this four, I can see the database. Now, because of this four, I can see the database has been come to here. Okay. I can see the database has come to 118 point something like data. Okay. Now, the same database. Now, when I bring the same data into the next level, now here you can see here. Your database is going to be the SAP HANA database only, because in the beginning, when I taken the class number 1, I told that even it is a cloud or it is on-premise or it is a public cloud or a private cloud, anything, you can take the underlying database always should be your SAP HANA database only. No other databases can be supported except HANA database. But here I have done the conversion. Now I'm using a word called as the conversion from SAP ECC to SAP new S4 core application, which is S4 core 104. What is this 104, sir? Anybody can give us some clue on this? What is this 104? No, you should be very proactive in giving the answers, sir, because you are my student, so I should not see any hesitating of giving the answers to me.
1909.
1909. Very good, sir. Thank you very much. Okay. So this is 1909. So what I'm going to be using the called as a part here, I'm going to be calling it as a conversion. Very, very important. Conversion. And this is called as the migration. Migration, I always to use the word for the database. And the conversion is a word I had to use for the converting of your application from your ECC to SAP S4HANA. So here I'm using the tool called as the DMO, Database Migration Optimizer, DMO. And here the tool which I had to use to do the system conversion from ECC to SAP S4HANA is going to be called as a SUM. SUM, Software Upgrade Manager. Software Upgrade Manager. And here, in SAP S4HANA, I can see some simplifications have been done. Simplifications. I'll tell you what are simplifications, everything in the comments. Simplification. I see some process has been simplified at the database level, not at the core application level. At the database level, I have seen some process have been simplified. All the secondary index tables and the index tables, second index tables and the pool table, cluster tables, total tables, all the tables are no more available in SAP S4HANA from today onwards. So I'm simplifying your data now. So all the existing means the data redundancy of the tables have been completely eliminated now. No more tables you can see. All the index and aggregate tables, total tables are removed. Now there is only one universal general entry table. We call it as the ACDOCA table for all the actuals. Actuals, I'm telling. Okay. So now when I bring the same 118.9 dB, okay, see here, very, very important. Now I can see in SAP S4HANA, it has been compressed. Now you can see the same 118.6 dB. After doing the simplifications, after I do the simplification, I can see 42.4 GB. Even this data I can carry in my smartphones also, my dear friends. Even this data, 42.4 GB or something like what remember. Okay, so 4 GB. Now tell me, my dear friends, tell me now, in this 42.4 GB, when I bring this HANA database, there is a hot data is there and there is a cold data is there. 42 GB. So when you take the hot data, okay, out of 42.4 GB, so my data 8.4 GB is here, and the remaining percentage and the remaining 44 GB, whatever the 44 GB you're calling, the 44 GB I'm bringing over here now. So this is called as my actuals. This is called as my actual data, and this is called as my historical data. Historical data. Now, sorry, this is 36. Okay, so it's a 36. Okay, I had to make it a 36. So 34. Okay, it's not a 44, it is a 34. Now you can see now. So the actual data is 8.4 GB, and the compressed data and the disk process GB is going to be up to 34, which is going to be called as the cold data. Now this 8.4 GB or even the 34 or up to 42.4 GB, this data I can carry in my mobile also now. Tell me now, wherever you're there in the world, even if you're there in Amazon forest also, if the network is very, very high over there, you can directly access to the Fiori and you can do the approvals, you can do any kind of transactions from your Amazon forest, so that you're not at office, but you're traveling, okay, so on the vacation, so you can also complete your work within a fraction of seconds, because the data has been resided in such a way that I have been given all the access to you because based on the Fiori. Tell me now, where is 593 GB of the data, where I have been compressed up to 8.4 GB of the data for the actuals? Why should I require all this 593 GB of the data? Out of this 593 GB of data, I required only this 8.4 GB for my day-to-day transaction for the reporting analysis. This is what exactly I call it as an advanced compression of the data based on the in-memory. So the words itself is telling that now you can see complete the actuals are going to be stored in a 5 point. These actuals are going to be calling it as the in-memory database. This is called as my in-memory database. So when I go into the column, okay, when I go into the next slide. Okay, the SAP HANA is a relational database management system. So it's combined. I told the last classes, in the first classes, what is OLAP and what is OLTP. OLAP is nothing but online analytical processing, and OLTP is nothing but online transactional processing. Okay, first class, if you see my first class video, you can understand about this. Processing into a single in-memory database. Now, as I told you that earlier, my OLTP system is separated and my OLAP system is separated. I treat three different data over there. One is going to be called as transactional data. Second one is called as analytical data. Third one is going to be called as acceleration data. Now I have made it as a one common database approach, where my SAP HANA database is both OLTP and OLAP compatibility. Now in one database, you can do all this activity. That is what exactly I can call it as single in-memory database, eliminating the disk bottlenecks and offering the groundbreaking performance. So what is the disk processing? What is the disk bottleneck? So, and now today, what is happening here? Now I don't want to get, okay, so now I know I don't want to get the data. Now what is the disk processing? When I come over here, so the complete disk processing is activated in the historical, and the actuals are going to be activated in your in memory. So I don't want to get the data from the disk processing. I will get all the data. Now actuals are in memory. So there is no disk processing mechanism over here. That is what exactly. So now here you can see the OLTP, the groundbreaking database system. Now, if you see here, this is the concept of in memory. So you can see here in memory, what I told that it is not a single database, it is a multi-tenant database approach, where you can get the accurate data up to date. What is the response? The fraction of seconds you will going to get the data, because I'm consuming the data from the in memory, not from your disk process. If I'm activating the disk process, I know that it will take in minutes, but I'm getting the data from the in memory, from the compressed database mechanism. So I get up to the data from the in memory. The in-memory database eliminates the pre-aggregates, means predefined aggregates are going to be minimized, means it has eliminated all the aggregations and the materialized views. Nothing. No aggregate tables from today onwards, my dear friends. No need to have any kind of aggregation on the top of your database tables. Now your database tables are going to be applied on the fly mode. So you can get any data from your database. No need to have any kind of aggregations on the top of your database tables, because my in-memory database has been built in such a way over there. So there you can have the data modeling. I'll tell you what is this data modeling and everything in the coming class. Okay, so not required now. Okay, so here I told that your database is going to be as a multi-tenant database. I told that SAP HANA is not a single database. It is a multi-tenant database where every database is isolated with each other, and it is dedicated for their own responsibility of extracting the data and giving the data back to you. So it's a multi-tenant database approach over here. So every database is going to be running on your system. Multi-tier storage. What is the multi-tier? Just now I told the actuals are going to be stored in your in-memory, and the historical data is going to be stored in your disk processing. So it's a multi-tier storage system where, as I told you yesterday also the same point, while you are rarely access the data is moved to the disk. Disk is nothing but your historical. And let's this, okay, and the frequently accessed data remains in memory. Frequently, whatever the data which is going to be accessing very frequently, that is going to be accessed from the in-memory. So this is exactly I call the database system with the different approaches over here. So this is called as the first important information where I have given the explanation on the HANA database. Where is my figure? Okay, this is what. This is my first information. So today we have completed only up to here only. This is the part we have completed from past 3 classes. Only SAP HANA, what is the in-memory. Is it worthful to all of you? So whatever the classes we have done from the past 3 classes, is it worth, or something like it's not going to be the good for your in-memory? So do you take some assignments in the next coming days about the SAP HANA database as a certification point of view?
Sure. Yes.
So I'll put on some assignments, okay? So in the coming, so tomorrow, day after tomorrow, maybe sometime I'll take on some time and I'll put some assignments on the in-memory so that you are not going to skip any things, okay? So something like you're not going to miss any topics. You are on the track on the day-to-day activity. So this is, madam, tell me.
When are you going to share the slides and everything?
Today you want me to, I'll share it today only.
Okay, that would be great. Thank you.
So definitely. I'll ask my support team to share this support desk to all of you. Don't worry about it. Okay. So I'll because I don't have the access, they let them share that. Okay. So are you feeling comfort in taking the classes from my side, or do you want some improvements from my side? Let me know so that I can also have some improvements. So because your feedback is very, very valuable to me, so that I can improve myself.
Yeah, I would say you need to slow down. You're too fast in talking.
Okay.
And,
why? I'll tell you the reason.
I'll tell you the reason. Attention on the the complaints that people are raising, questions that people are raising during the session.
Okay. Why I'm a little bit fast? I'll tell you the reason, sir. Because see now these topics, whatever the topics I need to explain, actually, so it has to be done. Okay, so within a time actually, so within 6 to 7 classes, because I had to, because a lot of things has to explain. So I had to summarize everything, and I had to be little bit fast, like so per kilometer something like I had to be little bit fast, about 40-50 speed. Okay, so why? Because if I'm not going to complete within a time, so what is happening? There will be delay on my financial subject. So these are going to be the important. I understand that I'm little bit fast in explaining, but only for these 2-3 classes only I'll be like this. But when I step down into the actual financial classes, you can see how I'm going to be the slow, because there I cannot go speed, because I had to explain technically and the functionally over there. So I had to be little bit slow over there. So that you can see the difference after 2 to 3 classes, because these are all the things I need to complete within next to coming 2 to 3 classes. So I had to be very little bit fast.
Yesterday you explained about the hot and the cold data, and today yes. on the paint that you are showing, the last column, Not this one, the other one. Yeah, so you mentioned that the AD and the HD, right? The AD and HD. So HD, is it the hot data? Are you referring to hot data?
Yes, yes.
So like yesterday you mentioned, hot data is something that is getting pulled up very quickly in 2-3 seconds.
No. You okay? The actual data is going to be pulled out. Okay, actuals are not. See, actuals and historical data are not the hot data. It is going to be called as historical data.
Okay, so it's not hot data; it's historical data.
Historical data, actual data, and historical data.
So what's the difference between actual and hot data?
Actuals means current 2 years, something like actual. So currently 1 year, 2 years of the data. So in 2019, 2018, you will get the data from your in memory, and all the historical data apart from 2018, 2017, 16, you will be moving all the data to the disk process. So this data will contain something about all the previous historical data, not for the current 2 years.
So historical is like cold data, is it?
Exactly.
Oh, okay. So yeah, okay. Thanks for clarifying.
Okay. So tomorrow we'll catching at the same time. Okay. So next class is ready for my. Okay, they are waiting for my class. Okay. Thank you very much.